The topic for today is the chapter 1 Chemistry of Representative Element, which is part of inorganic chemistry. Today we will study the group trend for the electrical conductivity, oxidation state, and melting boiling point for the representative elements. Talking about the group trend means regularity in the properties. Group means we are considering the elements that are located in the group in the periodic table. So group trend can be defined as the regular variation in the properties of the elements in the group of the periodic table. If throughout the group the behavior is regular, it is considered as a trend. If there is any irregularity or abnormal behavior, then it is termed as an exception or anomaly. Since we are considering the representative elements, so we will be focused on the S and P block for both the three trends. The first one, electrical conductivity. It is the measurement of the material's capability to conduct the electricity. How good a material can conduct electricity is the electrical conductivity of that material. For the group trend, for the representative elements, the electrical conductivity varies. Alkali and alkaline earth metals shows the highest electrical conductivity. You get this in reason as well. Why? Because they have greater atomic radius. Since they have the greatest atomic radii, so the electrons can be transferred easily. If the transference of electron is easier, it means they are good conductor of heat and electricity, so they have higher electrical conductivity. In this table, you can see that for each group, the trend of electrical conductivity is mentioned. The alkali and alkaline earth metals, the group 1 and group 2A, have the high electrical conductivity. As we discussed earlier, that it will be in your scientific reason as well. For group 3A, the electrical conductivity is moderate. For group 4A, the electrical conductivity is variable. Carbon shows poor electrical conductivity. Silicon shows moderate electrical conductivity, whereas germanium and tin shows moderate electrical conductivity, same as the silicon, but lead is a poor conductive. For the group 4A, we have moderate electrical conductivity, and for the group 6 and 7 halogens, the electrical conductivity is poor. Noble gases, as their octet is complete, so they have very low electrical conductivity. You can see that throughout the group there is wide variance in the group trend of electrical conductivity. Now talking about the oxidation state, it is the charge that is assigned to an element in the chemical compound or the combined state. The oxidation state of the element depends upon its position in the periodic table. This table shows the positioning of the elements in their respective groups along with their oxidation states. You can see that the oxidation state is also varying throughout the groups. For group 1A, it is +1. For group 2, it is +2, and then so on. And you can see that for the noble gases, as I stated earlier, their octet or outermost shell is completed, so their oxidation state is 0. They are non-reactive, highly stable. The third one, group trend for the melting and boiling point. It also significantly depends on the position of the element in the particular group of the periodic table. For example, in the group 1A, the melting and boiling point is low. Why? Because the atomic radius has increased, which results in weaker metallic bonding in the crystal lattice. And why did I report metallic bonding? Because group 1A is alkali metals. They are metals, so they have metallic bonding. For group 2A, their melting and boiling points is much higher as compared to group 1A because they have much stronger metallic bonding. But there is an irregularity from beryllium to barium. You might get it in your multiple choice questions that which element has the highest melting and boiling point in the alkaline earth metal or group 2A. So it is beryllium. And for magnesia, it has the lowest melting and boiling point. For group 3, 4 and 5th, there is variation because of the interatomic forces, structure difference and the physical state may also vary. For group 6 and 7, the melting and boiling point regularly increases. The state may change. If the state is of gases, it is in discrete form, and for solids, as they get aggregated, it is the highest melting and boiling point. For the group 8A, the melting and boiling point increases regularly. Why? Because of the van der Waals forces of attraction. You can see here that for the melting and boiling point, there is a wide range. There is no particular trend. For each group, you have difference. This is a chart that shows the melting and boiling point for group 1 till group 8A. This shows the versatility of the melting and boiling point as well. This table is respectively for the melting point. So you might get this most probably in the multiple choice questions or in the scientific reasoning. Why? Because if you are asked to describe it in the short question answers, then they might give you one property or two property, but the matter here is not generalized as every specific group has multiple variants, which is not similar to the previous group trend that we studied for the atomic radius, ionization energy and electronegativity. How you will get the questions? I'll share this in the next video. Make sure to watch that video, and if you have any question regarding this, that how you will get the question in your board examinations, how you should attempt the questions, you can reach out to me, you can ask me. This is all for today, and we have covered the topic of chapter 1, chemistry of representative elements, the group trends for atomic radius, ionization energy, electronegativity, oxidation state, melting boiling point. So all the properties have been compiled. You can go through all the videos. Thank you so much. This is all for today.